Hi, in this video we're going to learn how to solve quadratic equations by factoring. At the end of the video, you should be able to solve quadratic equations using your factoring method. Let's begin with review of your basic concepts. We will start with quadratic equation definition. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c is equal to 0. A, B, and C are all real numbers, but A is not equal to 0. It can be positive or a negative number. In here you have examples of quadratic equations, but only the first one, x squared plus 5x plus 6 is equal to 0, is in standard form. We mention standard form, and we need to always remember how the standard form looks like. It should start with an ax squared followed by the x term and then the constant. We need the quadratic equation in the standard form to be able to factor it correctly. We have factored expressions including many quadratic expressions, but this time we are going to learn how to solve, how to find the solutions or the values of the variable, or basically the x, in our quadratic equations. Let's have some more basic concepts. As a review, to solve or find the solution, we will use the zero factor property. The definition of a zero factor property is that if a and b are real numbers, and that if a times b is equal to 0, therefore a can be a 0 or the b is equal to 0. That is, if the product of the two numbers is 0, then at least one of the numbers must be 0 to further explain. It might be that at least one should be a 0, or possibly both are equal to 0. Here are the steps in solving quadratic equation by factoring method. First step, make sure your equation is in standard form. Step 2, factor completely. Remember, there may be cases of GCFs. Step 3, use the zero factor property to set each factor with variable equal to 0, and then you should be able to find the solution. Step 4, you can also, of course, check if the value of your variable will make the equation true. Let's have your first sets of examples. Here, as a start, it's already in the factored form. As a review of zero factor property, if you are able to factor your equation, your trinomial part or the quadratic part, you may now equate each factor to 0 to find your solution or the value of x. So you have the first part, 2x plus 3, equated to 0. And then solve minus 3 minus 3, you get 2x is equal to negative 3. Divide both sides by 2, and so you have x is equal to negative 3/2. That's the first solution. The second part of your factor is 5x plus 7. You also equate it with 0. Minus 7 divided by 5. You have x is equal to negative 7/5. And that's your solution. What you need to notice is that if there's a number in front of the x, your solutions are in fraction form. These kind of problems are difficult to work out manually in a graphing method because it's difficult to estimate the location, difficult to accurately determine the location of the solutions of 3/2 and 7/2. Sometimes it can be easy, but if the fraction gets complicated, it's difficult to graph the solutions accurately. So for some cases like this, you may rather use factoring method rather than graphing method. You have your second example. You have x is multiplied to 2x plus 4. X is considered the part A by zero factor property, and 2x plus 4 is the B. So x is equal to 0 is immediately done. That is your first solution. Your B part is 2x plus 4 equate to 0, minus 4 minus 4, and so you have 2x is equal to negative 4. Divide both sides by 2, and so you have negative 2. And so your solution sets, there are two solutions for your second example. Your solution will be 0 and negative 2. We didn't do the factoring yet. This part is showing as a review how you apply your zero factor property when you were able to factor your problem correctly. Let's now start with your actual problem that starts with factoring. Let's have the first example. You have x squared plus 2x is equal to 8. As you can see, your example is not in standard form. First things first, you need to write it in standard form. To write it in standard form, we need to get rid of 8 on the right side by subtracting 8 both sides. So it becomes like this, and so the right side becomes 0, and so you have a standard form. And now you're ready to factor. Supposed to be, if you factor it step by step, you need to factor negative 8, and you have factors 4 times 2. Since it is negative, which would be negative, so that when you add between 4 and 2 and you get a positive 2, it should be 2 is negative. So here it is. This is your correct factor. And now you have the correct factor. You may now proceed with your zero factor property. Equate both factors to 0. First part, here it is, minus both sides by 4, and you find your first solution. Second part, x minus 2 equate to 0. There it is, plus 2, and you found your second solution. And your values of x is negative 4 and 2. Watch out, it's not in parenthesis form because it will make it a ordered pair. Okay, you use this symbol so that it means both are values of x. Next, again, you have x squared is equal to x plus 30. It's not in standard form. We need everything on the left side, so minus x minus 30 on both sides. And so you have your standard form, negative x and then negative 30. You may do it individually so you don't get confused with the distributive property way of subtraction. And it becomes negative x, negative 30, because if you subtract 30 on both sides, negative 30 appears on the right side, and that's your standard form. What's the factor of 30 that we can use? Of course, you can use 5 and 6, because we're after of a negative 1. Between 5 and 6, which should be negative 1, when you add, it should be 6 is negative, because 5 plus negative 6 will give you a negative 1. So here is your correct factor. And now applying your zero factor property, x minus 6 is equal to 0, plus 6, and you found your first solution. Your second part, x plus 5 minus 5 minus 5, and then you get your second solution. The solutions are x is equal to negative 5 and 6. Okay, let's try some more examples. Solve 3m squared minus 9m is equal to 30. Again, the given is not in standard form. We will start by applying your equation properties by subtracting both sides by 30. So this becomes a 0 and you found your standard form. Here you need to factor 3m squared, which is your leading coefficient, leading term. You have 3 times m, and then negative 30 should be 5 and 6. What should be the correct factor? Well, it should be, at the beginning, you should have noticed that they are having GCF. You can factor out the GCF, which is actually 3. Take away 3 here, take away 3, it becomes 3. Take away 3, it becomes 10, because 3 times 10 gives you 30. Now it looks way easier. What factors of 10 will give you a negative 3 as a sum? Of course, 2 times 5, there's no other. Between 2 and 5, which would be negative, it should be negative 5. And so we're ready. The first part of the solution is actually m plus 2. We can already discard 3. I will explain later. So minus 2 minus 2, you found your first solution, negative 2. Your second part of the solution is m minus 5, and add 5 on both sides, and your second solution is positive 5. And we found your solution, negative 2 and positive 5. To explain about 3, a common error is to include the common factor 3 as a solution. Only factors containing variables lead to solutions. If you happen to encounter again GCF, you may discard them when you are ready to apply your zero factor property. Okay, and I guess this will be your last example. To write this in standard form, you need to add both sides by 64. The correct factor of 64, if you notice, it's a perfect square. It should be 8 times 8. Or you could actually write it as a repeated factor or square of x plus 8. But we don't need that part. We need to find the solution. We will separate your original factor by part A according to zero factor property, and then part B by zero factor property. But they are just the same. The solution will be just the same, negative 8. To explain, there is no need to write the same number more than once in a solution set when a double solution occurs. Actually, if you're going to graph this, making this 0, making this a 0 equal to y, this is actually a case where your graph has a vertex on the negative 8, wherein the graph intersects only once on the x-axis because the vertex location is on negative 8, 0. That is your location of your vertex, where x is the solution. That is why there's only one solution. Okay, and that's it. You can review the video, play and pause, whichever problem is similar to what you're actually working. Thank you.